All right, everybody. Thanks for being so patient. We're going to get the webinar started here, and as people come in, we'll just do our best to answer their questions later on, which leads me to some housekeeping items. All of our attendees, you are muted at this time, but we'd really encourage you to use the chat function if you're participating online and ask your questions, and myself, Alyssa, and Ben we'll do the best to relay your questions to the panelists. So without further ado, I'd like to introduce our project manager here, Ben Forrest. He's going to give a quick introduction to you all on what CoRDS is. Many of you may know that already, and also a little background on Sanford Health. So Ben, would you take it away?
Awesome. Thank you, Austin. First of all, thanks everyone so much for joining us. This is our second webinar. We're looking to do these every quarter, and so I hope that you'll all stay tuned and check out future instances of this webinar series. We hope that this is a place where everyone can learn a lot and also interact with other participants in the CoRDS registry. So I guess first and foremost, for those of you who aren't familiar with CoRDS, we are a free international registry for all rare diseases that's sponsored by Sanford Research, which is the research arm of a hospital system called Sanford Health, located in the Dakotas in the central part of the United States. CoRDS is kind of spun out of our rare disease research activities. We understand, coming from the research perspective, the importance of having a registry when you're trying to take a therapy or some sort of a therapeutic device or injectable or biologic to the market. Once you hit that clinical trial phase, you need to know where the patients are, and you need to kind of know a little bit about how the disease is progressing so you can organize your trials and everything. So we intimately understand the role that a registry plays in the process, and we seek to provide a registry to every rare disease community out there that needs one. We are disease agnostic, so to us it doesn't necessarily matter which disease you have. As long as it's a rare condition, we are here to help. And so please, after the webinar, if you have any questions about the registry, you'd like to learn more, or if you yourself sit on the board of a foundation or a nonprofit patient advocacy group, please by all means reach out. We are more than happy to talk to anyone about what we can do to help them and the people that they serve. So in the interest of time, why don't we get the ball rolling here on our speakers. We've got two great guest panelists with us this episode, and we're going to be talking about finding your genetic diagnosis, both from the perspective of a patient. We're going to hear from Seth, and then also from the perspective of the clinic. You know, how does a sample get processed in the lab, and what does that whole thing look like from the clinical side? And we'll hear from Rob on those things. So Austin, I'll give it back to you.
Great, thanks, Ben. And just a quick call to action for those of you interested in reaching out to us. You can email us at CoRDS, C-O-R-D-S, at sanfordhealth.org, or you can call us, anytime, probably after this webinar, since we're all busy talking to you right now, but that's 1-877-658-9192. So Seth, I've unmuted your mic. If you can share your screen for us, I think we're all very excited to see what you have to present. Looks like we've got almost 50 attendees so far, so I hope there'll be some good discussion afterwards.
Awesome. I believe everyone can see my screen. Is that correct? Right, Austin?
Yep. Yeah, we can see and hear you loud and clear.
Perfect. Awesome. Well, thanks again for having me here on this webinar, and I'm excited to share my story and talk to you a little bit about my journey as a patient advocate and continuing to support others in the rare disease space. So a quick background before I get started is just for disclosure purposes. I do work for my career as a partnerships manager at Inspire. It's a social health network that connects patients and caregivers to one another. And I also sit on the board of trustees for the Huntington's Disease Youth Organization. But this right here is my personal story. So that's all aside. I just wanted to kind of throw out everything I say here is based off of my own views and my own personal experience. So I'm going to just get straight into it and talk about how I grew up in a family impacted by a rare neurological genetic disease known as Huntington's disease. I may also uh, bring it up as HD, and it slowly deteriorates a person's physical and cognitive abilities. People say it's kind of like having ALS, Alzheimer's, and Parkinson's all at once, because it just, it has that cognitive decline as well as that physical decline. And once diagnosed, the average lifespan is about 10 to 20 years. And unfortunately, just like many other rare diseases, there's currently no cure. And I actually started learning about it because of my mom. And so when I was actually about 12 years old, I noticed something different with my mom. I noticed that she had poor balance and wobbly movements, often tripping and falling over, having neighbors who thought she might have been drinking during the day, even though we knew she wasn't. There was times where her and I would just have a normal conversation, and then the next thing you know, we're arguing over something. She's angry. We're, um, just talking about, the just sorry about that. We're just talking about what is, what's happening. So, this is going on. She's either depressed, she's angry, she's frustrated, these mood swings. Doctors are just saying, hey, she has major depression, she has mood swings, they don't know what's going on physically. And it got to the point where my dad and I, and some of my aunts and uncles had an intervention with her. We sat her down and said, hey, we need to figure out what is going on, or otherwise we have to, you know, do what's best for ourselves. We need to figure out how we can help you, but also how we can help ourselves, because it got to the point where it was constant stress every day, and my dad and I were just kind of running out of options, and it was either, hey, we're going to leave, or we're going to check you into a mental facility to get evaluated and see really what's going on. Luckily, she chose the latter. She obviously didn't want us to leave, but I'll tell you right now, she was not happy knowing that we wanted to check her into this facility. And after a lot of doctors visiting with her and these tests and evaluations, that's when they sat down my parents to tell them that my mom had Huntington's disease. And then from there, they decided to sit me down. And at this point, I was about 15 years old. And I remember they sat me down at the kitchen table and said, hey, Seth, we want to let you know we figured out what was going on for the last about 5-7 years of her being misdiagnosed. But for me, I still didn't understand what Huntington's disease was. And so I did what any other teenage kid would do. I Googled what is Huntington's disease. The power of Google sends me all this information, and I see, oh yeah, my mom has this symptom. Oh, and she has, decline of concentration, or she's depressed. And it really just started making sense. But at the same time, I didn't want to lose out on that normal childhood. I felt like I had to grow up a lot faster and be a parent to my parent and figure out, what do I want to do with my life? But throughout those teenage years and throughout high school, I really just wanted to try to focus on myself. And I really just didn't want to do much about HD. I would stay at friends' houses, stay after school, play sports, just do anything I could just to stay away from my chaotic household and really just kind of focus on myself and not have to worry about it. it wasn't until I was a freshman in college where my mind really shifted. And that's when I started doing more research on what the disease is, what it entails. And what stood out was that HD is a genetic disease. Now, back in my junior year in high school in biology class, I did one of those Punnett squares. And I remember talking to my teacher about it and saying, oh, my mom has this disease. But when we did the Punnett squares, because I was told the father has a dominant genes, I was like, oh, I'm not at risk. But that's obviously not how it works with this disease. So when I was a freshman in college and started noticing, oh, wow, I forgot something, or oh, I dropped something, and it reminded me of my mom, I said, wait a second, is this HD, or is this just me being a clumsy guy, or me just simply forgetting something? So I spoke actually with my aunt and my sister about whether or not I should go through testing. And I realized my freshman year, I wasn't ready to go through it, and it was probably all in my head. I was overthinking it. But I really wanted to do something because of those past years with my mom, not knowing really what HD was and how it really impacted her life. So a good friend of mine, Max, him and I decided to put on this 3-on-3 basketball charity event called Hoops for Huntington's, raising money and awareness for the disease. Did that for 3 years while also being a full-time student. And it was really just powerful to see how I was able to bring a lot of friends and family together for this event every year, and then also raise awareness about why I did the event. And it was just very exciting to do. But I kept thinking about whether or not I had this disease, and I really wanted to plan for my future because I think that if I tested negative for the disease, I'd still have this survivor's guilt where I may have felt disconnected to my mom or my family or the HD community. While if I tested positive, would I have to change career paths? Would I still want to have a family and a house? I would always just question, what would I do depending on what side of that coin came up, whether it was heads or tails. Ultimately, I was just tired of living with the unknown, and I'm a big planner, so I decided to go through testing. So here it is. 20-year-old Seth going through genetic testing. I didn't want to tell my family. I only told a few friends. The reason for this is I value family a lot. I really want to do what's best for them. That being said, my mom was still alive. I didn't want her to worry about me, to stress. I didn't want to add more to her plate, especially if the results came back positive. I didn't want her to feel guilty. My dad was the caregiver for my mom. Didn't want to be another burden or overwhelm him. And then, as mentioned, there's my older sister. Because she's also at risk, I didn't want her to feel pressured, like, okay, Seth's testing, so now I have to test. So I told a few friends, and I decided to get a referral from my primary care physician because the only other doctor I knew, or the neurologist I knew, was my mom's neurologist. And in my mind, again, at the age of 20, I thought, okay, well, I can't go to him because he works with my mom and he might say something to my mom or my dad. And of course, I didn't know what this whole term of HIPAA was, which obviously it would have been fine if I went to him, but I just decided to go through my primary care and got a referral to a neurologist. And this happened in March of 2011. I went in, spoke with him. He gave me the HD 101 rundown, asked about the history, all these things I already knew. So he told me to come back in 2 weeks for my results. And when I went back, that's when I realized my life was going to change no matter what happened. And what's interesting is I didn't go through genetic counseling. And one, it's because I didn't know really what a genetic counselor did, what their role was, who a genetic counselor was, and because they weren't involved within my genetic testing experience, which I wish they would have been, because I would have learned more about my next steps in my journey. So what I ended up finding out is the neurologist told me I tested positive for Huntington's disease. Now, this means that I am a gene carrier. Luckily enough, I am still pre-symptomatic. But here's the thing, is that I know what my fate is going to be. I know that I'm going to slowly deteriorate, both physically and mentally, just like my mom. So at this point, I thought to myself, okay, well, my options are I don't do anything about it. I don't worry about it at this point, or I use it as motivation to fight back, to get more involved. And that's exactly what I decided to do. I dove right into it. I wanted to help volunteer for the one of the national organizations for Huntington's disease, known as the Huntington's Disease Society of America, also known as HDSA. I joined their chapter board. I also joined this National Youth Alliance that falls under HDSA, that supports young people. But I wanted to do more, so I became president of both of them. And I was sharing my story, and I was raising awareness, and I was doing all I could, not just for myself and not just for my mom, but for all the people I met within the HD community who I was really fighting for and who really inspired me. And over time, I really wanted to focus on a set group of people, which are young people who are impacted by HD. The reason for that is myself being a young person, I didn't know much about HD. I didn't understand it. I didn't connect with another young person until right before I tested. And connecting with them really made a huge difference because I knew I wasn't alone. I wasn't the only one going through this. They understood me. They understood my needs. So I reshifted my focus and I decided to join the board of trustees for the Huntington's Disease Youth Organization, also known as HDYO, or as the young people call it, HDO. And the mission of HDO is to support young people impacted by Huntington's disease worldwide. We provide social, emotional, and educational support. It's an amazing organization where we can make sure people find the right educational content, the right support, connecting them with other young people, but also working with parents and professionals on better supporting young people. Because I didn't have an HDO, I want to make sure other people are familiar with what we provide and making sure they know they aren't alone in this fight and that we can help them navigate their journey to make sure that they have the right resources and services when dealing with this disease. So my biggest thing is it's important to know your resources. As mentioned before with HDO, providing the social, emotional, educational support, I think it really helps with all rare diseases, all health conditions in general. One of the biggest things I emphasize is that social support. Really finding people in your community to connect and talk with is important because you know that you're not alone in the fight. You can connect with them, you can hear about their experiences, maybe even get recommendations of who to go to for a doctor or specialist, or learning about different conferences, or even just connecting and talking with them, whether it's in person or online in some capacity, and going to that point with that emotional support. So as mentioned before, I didn't tell my family at first, but I wish I did. At least I wish I told my dad and my sister because I felt like I was hiding the secret. It took me about, I'd say, 3 years to tell them. And again, I had my friends who were very supportive at the time, but having the opportunity now to be open with my family made things a lot easier for me. I felt more comfortable. I wasn't hiding any type of secret, and I could kind of go back to being myself again. But what I also learned over time is finding the right support is big. And it's important to take care of yourself, whether you're a patient or a caregiver, and connecting not just with people in the community, such as your peers, but also connecting to a professional. So whether it's, again, a specialist, a psychiatrist, a therapist, an in-person support group, an online support group, these are great tools to use and to explore when trying to find that support. But more importantly, the biggest thing I'll challenge everyone on today is being able to be vulnerable, to open up. So when you're having a bad day and someone says, "How are you doing?" You don't have to give them the typical, "I'm good, how are you?" You give them the, "You know what, I'm having a tough day and I need to connect with someone." Or you open up with them, because if you can be vulnerable, it really goes a long way to, one, get the right care that you need, but two, get the right support that you need as well. And the last thing is the educational support. Again, finding the right materials to help you better understand and cope with your condition. A lot of us go to Google when we find out about a diagnosis or a condition that runs in our family. And I do it myself, but imagine getting the right resources from the beginning, such as like a packet of useful information of which nonprofits to go to learn more about, which support groups are available near you, which support groups are online that have other people that are going through a similar situation, and making sure that you're educated and finding the right materials that will guide you throughout your journey. So not just when there's newly diagnosed, then what are those next steps that you have to take, whether it's financially, with healthcare, medications, research opportunities, clinical trials. There's a lot of things out there, and it's just trying to find the right information. Now, I'm going to quickly speed through this part just based off of time, but a few things I wanted to share. Last January, actually around this time, I had the opportunity to do a TEDx talk in my hometown, which was even cooler. The theme was inspire others. And I was able to share my story going through genetic testing, and it really opened my eyes and made me realize it's not just about supporting the HD community, but the rare disease space as a whole. And from that, I really took off on sharing my story through articles, podcasts, all these different speaking engagements, not just around the country, but around the world too. And it's been an amazing opportunity to just learn about the unmet needs of the rare disease space and seeing how I can help them and how they can help me. It's really valuable to connect with other people who are going through similar situations. And I'm fortunate enough to call a lot of people in the rare disease space some of my closest friends. I think it's important also to find people who are going through a similar situation, as well as those that have already maybe gone through your journey. So for me, it's obviously connecting with other young people impacted by a rare chronic condition and learning from one another. And I'll leave you kind of with this a few last minute notes, which is, if you want to get more involved, don't feel like you have to, kind of the whole mindset of go big or go home. Start off slow. Maybe it's doing a blog post or a social media post, sharing your story. If you don't feel comfortable sharing your story, share about the condition. Maybe you have a family member you want to just say, "Hey, I have a family member impacted by this. I wanted to share more about this." Talking to people at your school, at work, conferences. Maybe you want to fundraise, do a Facebook birthday fundraiser, or sign up for a race. Do a social outing. Go to a restaurant who does give backs and gives back 10%. There's so many different ways to get involved, and this is something I'm very passionate about, is finding your way of getting involved. Figure out what you enjoy to do, and how you can make it into a way to raise money and awareness for your condition. I'm happy to connect. Here's some of my information. I have a website. It's, I would say, a work in progress, but it's definitely made some, I've made some great improvements. I left a link for my TEDx talk, which I'm sure you can just YouTube my name and my email. I'm happy to connect with anyone who wants additional support or just looking to connect, or if I can help them in any other way, please don't hesitate to reach out. And now I'm going to pass it along to my co-presenter, which is Rob.
Austin, should we dive in, or do you want to take questions? All right. Can everyone hear me okay?
Sorry, Rob, you might not have been able to hear me there. I was just trying to give everyone a call to action. Can you hear me now, Rob?
Yep, I got you now. Sorry.
Oh, that's okay. Yeah, so we will hold questions for Seth until the end there. And just a quick call to action for all the attendees. If you can think of ways, you know, that Seth might be able to help you discover ways you can get involved with in your rare disease or the rare disease community as a whole, please hold those questions for the end, and then we'll present them. But without further ado, I'd like to introduce Rob Pyatt, who is a laboratory director here at Sanford, and he's going to tell us a few stories on the diagnostic journey from kind of the science side. So Rob, go ahead, take it away.
Thank you, Austin, Ben, Alyssa, and the entire CoRDS group. Up until I moved my office into new laboratory space a year ago, I was just across the hall from the CoRDS group, and they are excellent. I hope you can struggle with me today. I have to admit, I've got a bit of a cold, so bear with me if I have to take a moment and clear my throat. You just heard Seth's personal perspective on having genetic testing done, and my job is to be the guy on the opposite end of that. So I'm a laboratory director where we do genetic testing. So I thought I'd take today and give you some examples of how we use genetic information to solve mysteries. And my kids always joke that they always want to do puzzles and things like that, and I never want to do them. I hate that. Because my day-to-day job is really solving puzzles. It's taking the human genome, understanding that information, and then applying it to answer questions, answer mysteries. So it's important for me to let you guys know that all of the personal images that I'm going to display today, we have permission. We want to make sure that all of our patients, regardless of at what point we interact with them, are treated with respect. So the first mystery that I'm going to talk to you about today is, what is the cause of my child's condition? So I've been with Sanford for almost 2 years, and this is a case that I interacted with in my previous job. So we had a girl, here you can see she's 7 years of age. When she was still developing in her mother, she was noticed to have interuterine growth retardation. She was really, really small in size. And at birth, she was very small for her gestational age, less than the 5th percentile. So 95% of other children that are born have larger weights and heights than she did. And this continued as she developed. She was noted to have proportionate short stature. So there wasn't any one particular anatomic region or bone that was small. She was small everywhere. It was proportional. And as she grew, that was really, she was in the 3rd percentile. So 97% of kids are larger, are bigger than she was. Now, this is surprising because her parents were of normal size. So the thought was that maybe there is something unique that occurred when she was developing in her genetics that may be contributing to that. When she was about 4.5, she was noted to develop some language delay and received some therapy for that. But by the time she was 7 years of age, She was seeing a medical geneticist, an MD doctor, to get their perspective on what might be causing her condition. And the doctor ordered a test called a chromosome microarray. And the question then is, can we identify what's causing the proportional short stature, the small size that you're seeing in this young girl? So what is a microarray? Well, in this case, as you often see with genetic testing, a sample of her blood was taken and sent to my lab at the time. And from that sample, we extracted DNA, and then we did a test called a microarray on that DNA to see if we could identify a change that had occurred in her genome that was causing her condition. A microarray takes about 4 days to actually practice to do. And in this case, what we do is we take a patient's DNA sample, as you can see here in that test tube in green, and we label it with one fluorescent molecule. In this case, we're just calling it green. And we take another control sample of DNA and we label it with a different color, in this case, red. And then we mix them together in equal amounts and we bind them to literally a glass slide that has probes on it to different spots of the genome. And letting us look at the different proportion of green fluorescence to red fluorescence allows us to look across her genome for regions, for areas that might be deleted or might be duplicated and might be responsible for what's causing her small size. So in each of these cases, I want to show you an example of what we actually see in the lab. I know this might be a little complicated, but I want you to appreciate the puzzle pieces that we have to work with. So in figure A here, you actually see the results from her microarray test. This is a region on chromosome 12. And you can see this green line here that begins to the left side of the figure and continues till about a quarter of the way into the figure. That's kind of a normal line showing that that region of her genome, she's not gained anything, it's not duplicated, or she hasn't deleted it. That's a normal result. Now contrast that to this blue region you see in the middle of the figure where that green line is now bottoming out. This is showing us that this region on chromosome 12, she actually has a deletion in. So at some point during her development, that part of her genome has been lost. Now below that green line, you can see a series of blue boxes. Each of these boxes is a human gene, and human genes code for proteins that do things in our cells. So when we look at this, we go, aha, we think we found a portion of her genome that's missing. What genes are in there? What functions might they have that could explain her features? So for us, the most important one is over on the left-hand side of that blue box, and it's the HMGA2 gene. And if I can get this, well, my PowerPoint may have locked up. Here we go. So in a normal HMGA2 gene, you see along the top here, we've got 1, 2, 3, 4, 5 exons. And you see this little girl's version of the gene here where we only have a portion of that. Her gene is actually broken. It's not functional. And this is a gene that we know now is involved in human growth, which explains what her condition is. It explains why she has this proportional short stature or small size. And the reason that we can get back is that she's got a chromosome 12q14 microdeletion. Now, when we identified this, this was incredibly rare. There were 8 other cases noted at that time. So we contributed ours to the literature so that our understanding of this condition is improved. So what kind of information then does our answer provide? We solved the puzzle, but at the end of the day, what good did we really do? Well, we know the cause of the child features. We have a diagnosis now, and this can provide relief for the parents. Both of them were tested. Neither of them had the deletion. So they now understand something of the medical course that their daughter might be on. This is important information for them if they want to have another child. Neither of them has the deletion, so the chance of them having a second child with the same condition is very low. In genetics, you can almost never say it's 0, but we can say it's very low. And like I said, now that we have a diagnosis, the doctor has information to guide treatment, both with her growth, with her intellectual development. The parents can work with the doctor and look to see what to expect for their development. And they can connect with families, just like Seth was saying. Connect with support groups of families that also have children with this same condition, and compare their experiences and support one another throughout growth. So that's our first mystery. Our second mystery, I thought I kind of, instead of doing a pediatric or kids example, do an adult example. So the individual you see here is Jeff Carlson. So Jeff was going to see his cardiologist, and he had two arteries that were blocked. One artery was 80% blocked, and the second one was 100% blocked. So these are both extreme emergency case situations. Well, as you can see in the bottom of the figure here, when you do have an artery blockage, one of the procedures that a cardiologist will typically use is implanting a stent. It's a simple medical device that can be used to break up that blockage, open up the artery, and to allow blood to flow through there again. The downside is when you do this procedure, there's a risk of forming a blood clot during healing. So individuals like Jeff are normally prescribed a blood thinner to reduce the risk of clot formation when they have this procedure performed. And in this case, typically Plavix is the blood thinner that's prescribed. But the question, the mystery that we're trying to get at here is Plavix really the right drug for Mr. Carlson to be on after his stent procedure? And what we're talking about here is really pharmacogenomics. In the past, we've all sort of been prescribed the same medication at the same dose, regardless of the fact that we may all have different responses to that medication, both how we're breaking down that medication and converting it into an active form that can actually be used to help us, and then how that active form actually interacts with our bodies. What we want to do then is use genetics to break up this kind of big heterogeneous group into individual people where we understand specifically how they're going to respond to these drugs. People who might have a good response, people who might have very bad side effects, people who might have no response. That way we can alter the dosage, switch to a different drug, so that we can specifically tailor medicine for them. Sometimes this is called precision medicine. So in this case, with Plavix, what we're looking at are changes in the CYP2C19 gene, because this gene has been shown, the protein of it acts in the liver to convert Plavix to its active form. So if you've got variants in this gene that are going to impact how well that protein actually works, in some cases, it won't convert Plavix to its active form as well, or in other cases, it might convert it into too much of its active form. So here again, I just wanted to show you an example of the puzzle pieces that we deal with in the laboratory. This is a genotyping result from a large number of individuals. Each one of those dots is a particular person where we have done genetic testing for one variant in the CYP2C19 gene, and this is indicated as a star 17 variant. You can see that some individuals are homozygous for one genetic variant. If they're blue, they're homozygous. They have two of the same variants at PT. If they're red, they're homozygous for the opposite variant. That's a CC. And if they're in the middle green, they're heterozygous. You've got one T and one C. And doing this genotyping then, we can begin to understand what are their genetics and how might those genetics impact how well Plavix is going to work for them. Because in this case, what we want to know is an individual a poor metabolizer? And we can define that based on an individual's genetics. If you're a poor metabolizer, you're not going to convert Plavix to its active form as well as other people might. So you're still going to have a risk for a blood clot formation. Same with an intermediate metabolizer. You can see this is typically 24 to 36% of the population. So this is a pretty good chunk of people that we're concerned about. So for these individuals, poor and intermediate metabolizers, pharmacists or cardiologists might recommend a switch to a different medication other than Plavix. That way, they're actually getting that therapeutic benefit and preventing a clot formation. If you're lucky to be a normal metabolizer, then Plavix is going to be perfect for you. But we can also identify individuals who are rapid or ultra-rapid metabolizers. So these people are going to convert Plavix to its active form much faster than normal metabolizers. So if they're given a standard dose, they're actually at increased risk for bleeding because they've got too much active Plavix in their bloodstream. So for these individuals, pharmacists and cardiologists may recommend backing off that dosage to a more reasonable level. So for the third mystery I thought we'd talk about today is my stem cell transplant working? So what you see here is a picture of Pierce. The little guy's 2 years old, and this is from 2017. He and his family went on a camping trip. They're out there, they're having fun, but his parents noticed that he was becoming lethargic. His eyes were swollen and they looked bruised. And once they got back, went to the doctor, did some blood work, and showed that he actually had acute myeloid leukemia, one of the common pediatric cancers that we could see. Now, Pierce had a rough time of it. He spent 115 days total in the hospital, had 2 rounds of chemotherapy, 31 platelet transfusions, 15 blood transfusions, and a bone marrow transplant. And that's really what I want to focus on today is the bone marrow transplant, because through genetic testing, we can help physicians be able to tell if that transplant is working or not. Now, I did not work specifically on Pierce's case himself, but I've done a lot of this type of work in the past, and I'm using Pierce as an example to kind of illustrate what we might do following a bone marrow. So what is a bone marrow transplant? Well, you've got a recipient like Pierce who has cancer or in some other way has a damage to the stem cells in their bone marrow. And these are the cells that give rise to all of the immunological cells we have in our bloodstream. So in this case, what we'll do is we'll treat Pierce or other individuals like this with radiation, with anti-cancer drugs to literally destroy their bone marrow stem cells, and then we'll replace them with stem cells from a healthy donor. And the question becomes after that, how do we monitor if this is working or not? How can we tell as the blood cells in our recipient's bloodstream begin to repopulate, to regrow? How can we tell if those are from the recipient and might still be related, in this case, to Pierce's cancer, or they're from a healthy donor and that transplant is working well to help fight that cancer? Well, we could do that through genetic testing, and we do that through microsatellite analysis. Well, again, I'm going to show you a couple of results just to show you the puzzle pieces that we work with every day. Microsatellites are just part of your genome that have repetitive sequences. They're typically 1, 2, 3, 4, 5, or 6 bases of DNA that are repeated over and over and over again. And those numbers of repeats can vary from person to person to person. This is the same kind of analysis that is used in forensics when they do analysis of evidence from crime scenes. So I thought I'd show you just one example here. This is from one microsatellite on chromosome 21. It's called D21S11. And in this case, that repetitive stretch of DNA is a sequence called TCTA. And that's repeated over and over again. You can see that at the bottom example, TCTA, TCTA, TCTA. So like I said, what we're interested here in this mystery is being able to tell the recipient's genetics, the recipient's blood cells from a donor blood cells. So here in the top column here, we have a sample of the recipient. This is pre-transplant at microsatellite D21S11, and you can tell he has 31 repeats of this TCTA repeat. Now, below that row, there's a sample of the donor, and you can see he has 24 repeats. So if we just do genetic testing, we can tell a sample from our recipient, who would have 31, from our donor, 24. Then in the third row here, we've got a peripheral blood sample that's post-transplant. And you can see most of this is from our recipient. It's the 31 repeat, but there's just a little bit that's showing up there from our donor. And here on our final row at the bottom, you can see a sample of saliva where we've got a lot still of that 31 repeat from our recipient, but we're showing even more there of our donor. So the question becomes then, is Pierce's transplant working? We've destroyed his bone marrow. We've given him a bone marrow transplant from a donor. And we have to be able to tell then, when the lab is sent a sample of his blood, what portion of that blood is Pierce's and might be related to the cancer, and that would be incredibly troubling, and what portion of that is the donor, where we know that's fighting the cancer. Ideally, what we want to see is this is all donor. Well, what you see here are the results from a bone marrow transplant analysis, where we're looking at 4 different microsatellites, 4 different regions of these repeats in the genome. We've got VWA starting on the left, THO1, TPOX, and CSF1PO. And our top row here is our recipient, and our bottom row here is our donor. The first thing we have to do are find these microsatellite regions where we can tell our recipient and our donor apart. And you can tell at VWA and at TPOX and at CSF1PO, these patterns between our recipient and our donor match. They have the same size repeats at these regions of their genome, so we really can't use things like VWA, TPOX, or CSF1PO to tell our recipient from our donor. But we can THO1. Both our recipient and our donor have 110 repeats, but our recipient has a 9 and our donor has a 7. So in all of our post-transplant samples, if we see a 9 repeat, we can attribute that. We know that is coming from Pierce's original cells. But if we see a 7, we know that's coming from the new donor cells. And I'll show you those post-transplant results next. Here we've got 3 different examples. So this is a buccal swab. It's a scraping of inside of the cheek. And then we've got 2 different samples of peripheral blood cells. One is we call CD3, one we call CD33. And if you look at THO1, the question becomes, what do we see? Do we see a 9 and Pierce's cancer might still be lingering or coming back? Or do we see primarily a 7 and his new transplant is stable? And you can see in almost every case, we overwhelmingly see a 7 with only just a bare hint of 9 there. This shows us that Pierce's transplant's working great, it's fighting his cancer, and hopefully he'll go on to be a healthy kid for a long time. And in fact, that was true. His transplant was a success. He was declared cancer-free in 2017. Much like the advocacy that you heard from Seth, his parents launched a huge social media campaign because it was very difficult for them to find a suitable bone marrow transplant donor for Pierce. And as a result of that, more than 9,000 people signed up to be potential bone marrow transplant donors on the bone marrow registry. So not only did their efforts benefit their child, who's now living a healthy life, but potentially 9,000 other people who need bone marrow transplants. So I hope you could appreciate some of the mysteries that we solve every day in human genetics. I'd love to be able to tell you that every case that we see in a genetic testing lab is a home run like the 3 that I showed you. Unfortunately, that's not the case. There's still a lot of information about the human genome that we don't understand. And at times we'll get testing results and we're just not quite clear of how they may or may not relate to a patient's medical condition. But only through additional research, additional work in the clinics, and additional works in labs like the one that I work in, can we get to that point of a complete understanding of our genetics. So thank you to Ben, Austin, and Alyssa.
Oh, thank you, Rob. And, I think that's a great segue into, kind of what we hope to do with our registry. If the registry is successful, we're able to kind of paint a bigger, better picture of what some of these rare conditions look like from a diagnostic level. And that helps inform people like yourself in the laboratory setting when it comes to looking at links between a genetic phenomenon and a phenotype. So what I'd like to do now is invite our guests to please direct your attention to the chat feature. Make sure that you select all panelists and attendees and fire off your questions. Let us know what are you wondering after hearing from both Seth and Rob, and we'll take those questions now here with the last 10 minutes or so. To kick off, while you're all going that way, I have a question for Rob. You showed that there was and you had your green line that was going across, and it showed the deletion on chromosome 12, I believe is what it was.
Correct.
You focused on one gene that is known to have a role in human growth, but that's certainly not the only gene in that region that's deleted. I'm wondering if you do any work to, exclude the other genes there from analysis, or if the other information that's lost in that deletion is important.
Absolutely. And especially in a condition like the 12q14 microdeletion syndrome, there aren't that many of those cases that are known. And each of them has slightly different sizes of deletions. So what we work to do almost on a research basis is work with the clinicians and families of other cases of which have been identified, so that we can compare both the size of the deletion and what genes are in there with the features that each of these kids or adults have. That way we can kind of make that connection between a gene that might be lost and then what features of the condition might it be causing. At times we get lucky because we have some redundancy in our genome. So at times you can lose a gene, you can knock it out, delete it, mutate it, but we've got other genes that'll compensate for that. Obviously, that's not always the case. And the HMG2A gene is a perfect example where if you do anything to break or disrupt that gene, it impacts human growth.
Thank you so much for joining us today and taking the time to answer that question. It was a great presentation from both speakers. Alyssa, it looks like we have a question from Aaron.
Yes, Seth, I'm going to ask you this question. This is a question from Erin. What do you recommend for someone finding difficulties, finding support and resources? She's joined a few online communities, but when asking for assistance or advice, posts tend to get hijacked or questions go unanswered. Any advice there, Seth?
Yeah, and that's always a tough one because I totally see that happening a lot within the HD community with certain support groups that I'm in, as well as you ask a question, you're finding specific resources, and then suddenly it takes off in a different direction, or someone else is, kind of overseeing that question. One thing I would say is see if there's any patient advocacy nonprofits focused on your condition and seeing what type of resources they may have. So again, sometimes it's just going to the power of Google and searching your condition and typing in patient advocacy organization or nonprofit, and then trying to reach out to see what resources they have and if they have any other type of in-person supports. And I know it's tough because it depends on the condition. But the other thing is, don't give up hope, because a lot of times it takes a lot of patience to find the right fit. Just like when we're looking for a doctor, we need to find the person who understands us and can relate to us. But even if it's maybe just finding a few people who responded, who didn't necessarily take over that post or take over that question, that you can maybe reach out to separately. Maybe you can message them separately and say, hey, thanks for your response. Would love to connect and learn more. So it only takes a few people to really get that support, and hopefully that answers your questions. But again, I could always dive deeper into some of these.
Seth, that was a great answer. Thank you for sharing that.
Yeah, and we do have your contact information out there. There was a question wondering what's the best way to reach out to you. So we went ahead and shared your website and your email address. So you might get a few inquiries.
Perfect. Yeah, I'm always willing to help. And, seeing even some of these comments on these different conditions, I think I can always try to at least see if I can help them out if they're looking for support people, or even trying to direct them to someone else who may have a better insight on that specific condition.
Absolutely.
Yeah, if I can piggyback onto Seth's answer to answer a question that Denny had. He's asking, how do you get more researchers excited, interested in studying a rare / not sexy disease? And I think Seth's answer is the key there. It's the family groups. A lot of the best research work has started with family groups raising money and funding the research themselves. And if, you know, I can't say that this is an accurate statement for everybody, but if you're able to provide a researcher with an interesting question, which is going to be whatever particular condition you're interested in, and some funds to look at it, you're going to have people beating down your door to do that. So I would just do what Seth did and work with patient advocacy groups to fund and support research.
That's a great suggestion, Rob, and I'd piggyback on that a little as well. Don't be afraid to reach out to researchers, and especially if you can become savvy enough in your rare disease and you understand maybe what gene or what protein is affecting your condition. Try to look for researchers that study that particular gene or protein, or maybe even just the organelle in the cell that it's primarily affected by or primarily affects, and look for those types of researchers, and they might shift their protocols to address some of your concerns if you provide that funding. So great suggestions there, guys.
Yeah, and another question I did happen to see, and I know we're running almost out of time, but the chances that medication will be found for a rare disease, and I'm sure Rob could answer, we'll probably have to piggyback on this, but my biggest thing is trying to do your research and understanding how the clinical trial process works, how does drug development works, because it does take a lot of time, and I'm still continuing to learn more about that concept. But I think it's also learning about it and then building a relationship with that company that is interested in your specific condition, or making someone interested in your condition by advocating for yourself and for your community. And then also, participating in clinical trials. That's a big thing. And it is a fear. Don't get me wrong. I think it's a very scary thing, because what happens if you get the placebo? And I think at the end of the day, it's the placebo is just as important, because then you can see if it truly has an impact and if you can get to that next phase in the clinical trial process. But the chances of the medication being found in a rare disease, I always try to stay optimistic. I think it really just depends on building that relationship with the pharma, biotech, life science company, getting them to understand that the needs and the voices of that community, and then working alongside with them throughout the clinical trial process to see if you can find a medication, whether it's to treat it or to cure it.
Yeah, it's clear that to do that, you've got to understand what the genetic alteration is, how that change in your genome is messing with the way the protein that's coded by that gene normally works, and then figuring out a way to correct that. So is it like the little girl's case I showed you, where you've got a loss of a gene, so it's simply not making the protein? Well, maybe there are ways to give individuals that protein in other ways so that they can get that in a supplementary fashion. Is it that you've got a smaller change in a gene, and maybe the protein now has lost some of its regulatory features, where it was very well controlled previously, but now it's not so controlled? So are there ways to potentially have a drug that would block that, so you can knock down that increased level of activity? So it's all about understanding the causes of each particular disorder and then tailoring our treatment to that. So we talk a lot about personalized medicine, and my pharmacogenomics example is kind of our first steps towards that. This is what we're really getting at, understanding on an individual basis what changes to your genome are resulting in changes to the way proteins function, and then what therapies can we give you to correct that.
Great, thanks, Rob. Rob, did you have to go right at one, or do you have time to take a stab at Leanne's question about having a family a history of a certain type of adenocarcinoma, and having siblings who have had cancer? How to weed through genetic reports and tell what's relevant?
Yeah, and let me hit on two, because Lucy right above that asked about an umbilical cord transplant. So this would have been for Pierce if we could have used cells from his umbilical cord when he was born. instead of a bone marrow transplant from an unrelated individual. That would have been great for them, because then you don't have to worry about finding a donor that matches you. They're your own cells, so inherently it's going to be a much easier course for that transplant. So if that existed, that would have been wonderful for him. Unfortunately, from what I understand of the story, that was not a particular option. And then the question about the familial adenocarcinoma, and this is challenging. What is clear in something like this is you want to go see a genetic counselor, you want to see a genetic specialist who's an MD, because they'll want to take a family history of you, just like Seth's talked about his family history, and look at both for everybody in your pedigree, all your relatives in your family tree, who's had that particular type of cancer, who's had other cancers that may or may not be related, and then layer onto that as well each of those individuals who has had genetic testing done and what their results were. And then that will begin to help you tease out, are the genetics we're looking at significant for the feature, in this case cancer, or do the two just happen to occur together and maybe not be related? I can't speak specifically to, I can't quite read the name of the person who wrote the question, but I can't quite specifically speak to her case. I'd really need to see the entire report, because I'm sure it's a little, there's got to be more involved there. But clearly, seeing a medical professional and getting a family history done would be a great first step.
Thanks, Rob. I want to be respectful of everyone's time and thank our presenters today. It was a great webinar, I think, and you provided a lot of value to everyone. Everyone who we didn't get to your questions, please email us those questions at CoRDS, C-O-R-D-S, at sanfordhealth.org. That's Sanford, S-A-N-F-O-R-D, health.org. And we'll do our best to track down some answers for you. So I hope everyone enjoyed this presentation. Seth, thank you. Rob, thank you. We look forward to working with you again.
Absolutely. Thanks, guys. Really enjoyed that.
All right, bye-bye, everyone. Thanks for joining. We'll have our next webinar in about 3 months, so keep your eyes open.
Excellent.